Good morning, good afternoon, or good evening, wherever you may happen to be, and whether you're watching live or archived, and welcome to another Nautel Wednesday webinar. Today we're talking about World Digital Radio, specifically Digital Radio Mondial, DRM. And to help me out with this, because of course I work mostly in the US and talk about other stuff, I've got some folks that, as always, know more than I do. My name's Jeff Welton, and with me today, I've got two special guests. One had to step away, so we'll get to him in a moment, but I've got our India sales manager, John Abdnour, who has been around longer than radio almost. John, welcome aboard. And John, you're not getting any audio there.
I said I'll take that as a compliment, Jeff. Good day to you, Jeff, and to everyone that's watching and listening around the world. It's great to be here and contributing as best I can. Hope we can pass some good information along.
We'll have some fun. Now, the funny thing, John, I was, of course, doing some almost like prepping for a radio show and doing some Googling last night, and I saw your retirement interview from 2017, and then I saw your retirement interview from 2020, and here you are wearing an Nautel shirt. I'm not sure you're doing the retirement thing exactly right.
No, that's kind of difficult for some of us. As they say, you find something you love and you don't work a day in your life. So,
Right.
full retirement for some people is one thing, and for some of us, it never felt like work. So we needed a little help in part of my former territory, and it kind of fills the days and gives you something to do. And you also are able to stay abreast of what's going on in the industry and stay in touch with friends.
Speaking of that, and that's a perfect segue, because of course we've got the question panel, and we'll touch that in a moment for the folks that aren't familiar with it. But you got a greeting from an old compadre from ITC. Mark Hill says hi.
Oh my goodness, hello, Mark.
So
that's blowing the whiskers off when we go back to ITC those days.
That's those cart machines. That's that going back a day or three.
Indeed it is.
On that, okay, so skipping to the other end of the technology, the other fellow who we will have with us today is Philipp Schmid. Philipp did have to step away from the microphone. Oh, there he is. Okay, and Philipp is currently muted, so there's the green button. Philipp, welcome, and glad to have you with us today.
I'm glad to be here today, and I think there's lots of stuff happening. We'll cover a lot of ground today, I think.
And so a couple of ground rules, folks. This is a DRM session. We know there's other digital radio formats where, though we may do some comparison here and there, this isn't a shootout about whose is best. We're here to talk DRM today. Also, of course, there's several different manufacturers, and we'll glance on those here and there through the day. But again, we're not saying one's better than the other. We're just trying to give you as much information as we can. On that note, we do take questions. A couple of folks have found the question panel already in your control interface. If you take a look, there's a place to enter a question. You put a question in, it pops up on my screen. If it looks like it's something that we'll be addressing later, then I'll probably defer it until later. Some of them we may end up answering by email after. This is going to be part one of probably at least a two-part session. So we're going to cover the surface right now, and we'll do the deep dive later. So, by all means, ask the questions, throw them at us. If we don't get to them today, we will get to them next time. If you are an SBE member, Society of Broadcast Engineers, any Nautel webinar does give you half a credit under category I of the SBE certification schedule. So something else to keep in mind. On that note, let's move forward and get on rolling. So one other note, and I mentioned it in a couple of slides as well, but you'll see slides talking about DRM 30. You'll see them talking about DRM plus. It's all DRM. Essentially, DRM 30 is 30 megahertz and under, so your medium wave, your short wave, and then DRM plus is anything above 30 megahertz, so FM. Philipp, I got that right, correct?
Pretty much, yeah.
I hate it when he says pretty much. It always makes me think there's a detail I'm missing. So It's kind of cool for us because there's also in the DRM-30, the lower band stuff, there's also long wave transmission. And John, we'd done some playing around with that before, haven't we?
Indeed, we have done some long wave work in different countries. Again, in DRM because it works across all bands, and not a lot of them, but there've been a couple.
Oh, all right. So we'll get rolling on that note. And of course, the NX series is the medium wave transmitter we'll be using to illustrate pretty much any AM related point today because, well, obviously it's the one we build and it's the one we know the most. The cool thing is that the efficiency's up there pretty good and it does handle most of the modes. Philip, and this will come in later, but we'd been talking about AMSS and AM or AFS earlier, and you just gotten confirmation that those are supported, yes? Or at
Yes,
least one of them.
absolutely. Yep.
Okay.
Yep. Maybe it might be better to talk about that in a little bit when we talk about simulcast and different modes, and it'll make more sense.
Yep, exactly. And there will be lots of acronyms. John, did I see you wave your hand earlier? Because
No,
definitely, if you're going to say, throw something at me virtually speaking, if you've got anything to throw in there. But we do have a lot of the NX boxes out there. We will be talking quite a bit about the deployment in India, and I know you were instrumental in that as well.
yeah, that was an exciting a project that Nautel worked with the All India Radio with, and we'll talk about that in a little bit of detail a little bit later on. But the map is impressive because as you can see, it indicates transmitters where we have transmitters installed that are all DRM capable. Not all are operating in DRM at this moment, but they're all easily modifiable to operate in that mode.
Exactly. And that was brings me up to one of the other things. There are a lot of folks with a lot of different companies working with this, and I want to throw thanks out to Digital Radio Mundial. We sent a request to Roxandra Obreja early today and got just asking for permission to use some things from the DRM handbook, and we got an almost immediate response. It's really gratifying to see that level of support. So shout out to the DRM handbook. I've got the link here. I'm going to leave it up for a couple of seconds so anybody wants to grab a screenshot can, and it'll show up later on in the resources. But this is probably one of the best resources for anybody that wants to learn the nuts and bolts and the really heavy technology behind this. I know I learned a lot more than I ever expected to.
It's an excellent go-to place, Jeff. Just an excellent place.
Yep. All right, moving forward a little bit. So what exactly is DRM? Well, it's digital modulation for the existing bands, so it coexists with analog. And the early iterations, especially with AM, and I'm going to date myself in a couple of slides, but early iterations were digital only. However, now you've got hybrid options. You can even have, and Philip, talk to me about this a little, and I know we'll get into it a little in detail later, but there's also almost side-by-side options, if you will, correct?
Yeah, absolutely. We've got a slide later on that shows that in a little bit more detail, so we can certainly do that. But the idea is, if you don't want to turn off your analog transmission today, well, you can go analog and digital side by side.
And I mean, historically, and this is one of the ones where, like I say, I learn something every time I do one of these webinars, primarily because I need to know at least a little bit. And just learning that the hybrid mode existed kind of was new information to me. So again, DRM-30, if you are reading something that's a little older and it mentions that, that's 30 megahertz below that. DRM Plus is above that, the FM band, or VHF rather, because you got band 1, 2, and 3. And band 3, you're up into 200 megahertz, Philip?
Yeah, exactly. It's a DAB band in essence, and DRM FM covers the entire VHF band 1, 2, and 3.
Okay, and the one thing that really caught my eye on this as I got through with the modes of operation and the different bit rates was there's a massive amount of flexibility in this system.
Oh, DRM is so flexible. I mean, it can do yoga on any day.
All right, that was not a picture I ever would have considered going together with this particular topic, but there you go. So this is the slide where I date myself. The inaugural broadcast in DRM was June 16th in Geneva during the ITU World Radio Conference. The reason this is cool because I was working in tech support then, and of course I get told to go somewhere, turn this transmitter on, take some measurements, make the customer happy, and come home. Easy breezy. And so around about the middle of June 2003, I got asked to fly to Orfordness, UK, England, east coast of England on the North Sea, old nuclear site. And so I'm standing in front of this transmitter, and the guys are adamant that you need to be here and it needs to be on. And I didn't know why. So I took this screenshot, but I was standing in front of a 200 kilowatt transmitter running DRM in England that was being received in Geneva on June 16th, 2003. So that was really kind of cool. Little side note, I think it was John maybe mentioned the pagodas. The Orford Nest site is an old nuclear test site, and it was designed, the nuclear test facility is still in place, or it was at this time, so that if somebody was working underground in the nuclear facility and something went sideways, it was designed to blow the concrete supports out from these giant concrete roofs that were geared to come down and seal the whole facility. Not so great for the folks underneath, but probably really good for the folks above ground. So that was just a little bit of history there as well. So that facility was used as a test site. Philip, that transmitter, do you know if that's still there? I know I don't. I was just curious.
I have no information on that, sorry.
No worries. So features and benefits, John, I'm going to get you to talk to these a little bit, but of course, digital modulation typically, especially for the AM bands and the lower frequency bands, isn't as subject to the atmospheric noise that tends to plague, like LED traffic lights, computer power supplies, all that. But there are a lot of things that this system does offer.
Oh my goodness, yes, it does indeed. And as you mentioned, the improvement in the audio quality over analog is remarkable because, like you said, we've done a lot of presentations over the years about the increased noise floor, for example, impacts particularly AM broadcasting because of man-made noises and so on and so forth. And converting it to digital eliminates the cracks and buzzes and pops and so on and so forth. So you get a much cleaner audio path without that kind of noise. And then as well, we can increase the number of channels that are able to be broadcast over a single analog channel. And not to mention the data services, and there's a sundry of data services that are available that can be transmitted along with that signal for well, you name it, as a slide shows, you know, text-based information, traveler information, a slideshow, so on and so forth. And DRM, it supports AMS, which AM signaling system, automatic frequency switching, the ability to hand the listener over to other frequencies on a network. So it can almost be a seamless network. And one of the a very important thing for public safety is the emergency warning functionality. Alerts can be sent out whenever necessary to alert the public to impending weather dangers, child abductions, things of that nature. And the system is also available to designed to wake up your radio, so you don't have to be listening all the time. It can be there in a standby mode, if you will. And when necessary, it can be automatically turned on and the information disseminated.
Yeah, one point on the AMSS and the AFS that you mentioned there, what's new in the industry now is that we have receivers, multi-standard receivers that can listen to multiple over-the-air broadcasts or IP streams over a 4G, 5G network or whatever IP connection you have. And so those receivers can listen to multiple audio streams. So for example, you could have your car tuned to a DAB broadcast, As you lose coverage from the DAB broadcast, the AFS system could signal, well, switch to DRM FM potentially. And if there's a DRM FM transmitter nearby, we'll switch to that. And receivers can do that very much seamlessly to the listener. So you can pass off listeners from one service to the next, or vice versa. You can pass them from an analog AM service to a digital service. So I think technology has come a long way, and it opens up a lot of flexibility to broadcasters.
Indeed.
And this, Philip, this is kind of tied into, well, basically what you're describing is the hybrid radio service that I know NAB has been working on, among others, correct?
That's part of it. That's the IP part of it. But I'm also talking about being able to hand off between DRM and DAB or DRM and AM, so as well as the hybrid IP stream. So the hybrid radio is one portion of what I'm talking about.
Okay, let's see, and I've got a request or a comment here. Appreciate the more open nature of DRM compared to other standards. Wonder how it works with the codecs. So it's basically a question about licensing, and that is probably a difference in that you don't pay a license to use the technology per se, but that the manufacturers do have some license fees for the technology used to generate the signal. So there are costs related to intellectual property. Of course there are.
Oh, absolutely, there is. Yeah.
You know, but
There
yeah,
are,
the difference. Sorry, Tom.
No, well, go ahead. I was going to say there are. That is correct, but that cost is actually built in to the purchase of the equipment.
Right.
So it's there. It's a one-time cost, and they may call it a royalty or something of that nature, but nevertheless it's there. But I guess it would be invisible to the user except for when you purchase the equipment.
Right.
There's no license fee to go on air or anything like that.
No, correct.
Right.
You need the equipment, and it's built into that.
Yeah. So thank you for that, Joel. That was a good point. He did mention that using older patent expired codecs or royalty-free ones would avoid this, and that's true to an extent, but most of them come with conditions of their own, whether it's not for commercial use or restrictions of some sort. So definitely there's always a decision and judgment call to be made when you come up with a technology like this. Component-wise, really, the only new components we add to the mix are the content server and the modulator. And I mean, I've got a brief description here, and we'll be doing a much deeper dive into them later. But Philip, is there anything you want to address on those?
Yeah, absolutely. I mean, the content server takes care of all your encoding and creating your data stream as for transmission, and then the modulator, of course, takes care of all the lower level signal parameters, and it will also include simulcast for AM plus DRM transmission and things like that. And there are two separate pieces because sometimes the content server wants to be at a different location than the modulator, so that way we can separate them over IP.
Right. And this is, it's a vast oversimplification, but I see a lot of North American based folks in the audience list. So I liken it to the content server being similar to the importer exporter in HD, and the modulator being more like the XGen.
Yes.
So that's
at a very high level, they're pretty much the same system functionality, correct?
right. Configuration wise, things are for AM. I mean, back when I was in 2003, when I was in Orfordness, and any of the DRM installs I did after, as I said, those were digital only. So content server, modulator, transmitter, antenna, bang, you're done, set it up. I mean, obviously there's some tweaking, but now with hybrid mode, you can generate an AM signal almost similar to an FM, whether it's separate antennas, separate transmitters, high level combined. You've got quite a few options now, correct?
Well, for simulcast on AM, our recommendation is to do it in the transmitter. No separate antennas or anything like that. It would just be all emitted from the same transmitter. On the FM side, there's a number of other options for sure. And
right.
I think we're getting to that in a couple slides.
Right, going forward, we'll talk quite a bit about the FM options. Hybrid mode does tend to be the easiest. The cool thing is that because in AM mode we do have so much flexibility with the operating modes, whether it's A, B, C, or D, and the individual bit rates, that we can make allowances for antennas that are less than ideal. Now, as with anything else, any change you make like that is going to impact your coverage. Accurate enough? You know, it's all a trade-off, yes?
Absolutely. You can either choose more bits on air or more distance. You can't have your cake and eat it too. You can't have super high bit rates and get super far range. Choose one or the other and match it to your conditions.
Right. And now, so somebody says DRM only accessible with internet, and that's a very resounding no. This is primarily an over-the-air technology.
Right. That's absolutely correct. It's just over your medium wave AM transmitter
Right.
band. Yes.
Well, there's one addition that people may not be aware of. When we talked about the content server modulator, the two have an IP protocol between between them called the MDI protocol. And it is possible to feed this MDI protocol to software, just IP apps, no over-the-air anything. And you can have the same presentation layer on a PC, on a smartphone, over IP only. So that's a unique aspect of DRM, that you can actually listen to DRM without over-the-air broadcast.
So that, especially in the instance of like a hybrid radio scenario that we were talking about earlier, that would actually really simplify that process.
Exactly, it would be very interesting. So you could either have your MDI stream over 4G and the over-the-air, and if you lose the over-the-air, you can switch to 4G and save on bandwidth going back to the over-the-air if it's available.
So that's again, flexibility is pretty amazing. So we're looking at an example here of a simulcast, and this is what you were talking about earlier. And I see the square wave on the upper sideband.
Right, exactly. So on the right, you would see your regular DRM block on AM, and here we're showing actually the widest possible configuration, up to 20 kilohertz. And we're able to accomplish that using advanced pre-correction techniques. We've got AM to AM, AM to PM corrections, as well as equalization all in there. And that allows us to be able to pass such a challenging signal. However, on the left, like you mentioned, there is the simulcast with the AM in the center, kind of triangular there, and the DRM on the upper sideband as a smaller block, and you can see it's half the size as the one on the right. And the idea is, and I think we've got another slide on that following, so I wonder if that one's actually better to talk about that. There we go. Yeah, that's exactly the one. Because the idea is to, if you don't want to give up on your analog AM listeners today, you can put on a DRM sideband. But in a previous screenshot, we actually showed you the X'd out configuration, where the DRM is on the right-hand side. Yep, there you go. By going back to the other slide, what you really want to do is put the DRM on the lower sideband. And the reason for that is that the tuning frequency in this case will be 9 or 10 kilohertz removed, depending on what your step size is in your country and depending on what configuration you choose. So you'll have two tuning frequencies here, one for the analog and one for the digital. But the digital is on the left-hand side. When it comes time, as shown with the white arrow moving to the right, to turn off the analog AM, and you want to fill in more digital carriers, you would replace that 9 or 10 kilohertz bandwidth with more DRM carriers. However, the tuning frequency for the DRM remains the same. Had you have you done it the other way around, moved it to the upper side on the right with the X, we would have then had to move that block down where the AM is, and then fill in the carriers. So now you have to tell all your digital listeners your frequency has changed. Whereas with the check mark, you can just simply turn off the analog at some point and turn on more bandwidth and maybe add a couple more side channels.
Jerry Higgins makes a good point that one of the benefits of this, and it's similar to hybrid HD, it takes the transition bump out in that analog listeners are not being left by the wayside, if you will.
Absolutely, it makes it a transitional technology, so that and we learned that we'll talk about it later in our initiative in India, where it started out as being digital only until certainly everyone realized you do that and then a billion analog listeners go away. So this makes it a transitional type procedure.
Right, right.
Very important, very important
John
for the
Van
future.
Milligan mentioned that Kiwi SDR has DRM reception, and he's listened to India via receivers based in India on the internet, and it sounds really good.
It
And of
does.
course, anybody who's not familiar, SDR software defined receivers, so there are several of them around the world that are available online, and they're picking up an over-the-air signal and just streaming the audio on the internet. It's kind of cool. I can tune in an actual radio on the whole other side of the world. I mean, and for those of us that grew up listening to a transistor radio under the blankets with a flashlight and, you know, in the wee hours of the morning when we were supposed to be sleeping, this is really amazing. I mean, it just astounds me. And I don't think I'm all that old, except in my mind some days. Oh, one of the things that we can offer too, and I'm going to flip back 2 slides. I hope I don't make anybody too dizzy with the back and forth. But one of the things, and we'll talk about it more later, if you take a look at either one of those pictures at the RMS power and then the peak power, especially on the digital only signal, that's a not insignificant difference, Philip.
Absolutely. You know, for planning purposes, you probably want to look at the 10 dB peak to average power ratio. So in your 80 kilowatt example here, well, you might want to size your equipment for 800 kilowatts. Now, as you drive your transmitter closer to its rated limit, we will essentially reduce that peak to average a little bit, and you'll still be within good MER signal quality metrics and that sort of thing. At that point, we're getting down to 7-8 dB. But if you have extra headroom in a transmitter, it might make full use of the available peak to average power.
And that's really worth noting. And for those that don't do the math every day in their heads, 10 dB is 10 times. So, you know, if you definitely want to be aware of that when you're putting up a new facility, that if you're looking at it, like I say, even with hybrid, you were talking 3 or 4 times. And if you're looking at an all digital down the road, you want to size it based on what that all digital power will be. So definitely make it part of the planning process. We've run into the same thing, well, and it's pretty consistent, right, with just about any digital modulation scheme, because you are dealing with a peak power situation. So let's see, talking a little bit about the options for channel bandwidth, and this was the thing that we got into earlier, where the different modes of operation for different ranges, but at the cost of coverage, or what was it you said, Philip? You can have your cake and eat it, or you can't have your cake and eat it too. Sorry, but you've got the option of whether you're going far or you're putting a lot of information in.
Exactly. So yeah, that table here is actually very good. You can kind of see that, you know, if you look at the widest, the 20 kilohertz mode on the right, you know, we can crank up the bit rate up to 72 kilobits, but you know, as you go down in robustness mode, then you'll go down to 13, but it will go a lot further. So right. A big step from 13 to 72. You know, it's a huge configuration range. But it will also manifest in how far the signal will go.
And this does come back to the DRM handbook that I was talking. This is a cut from that. They provide a massive amount of information, including things like the usable field strength for specific bit error rates, BER being bit error rate. Can you talk to that a little bit too, Philip?
Well, I mean, bit errors, you know, unlike analog, where any noise would, you know, degrade the quality of your analog signal, in the digital world, you know, it will affect bits. You know, it will, as it decodes the constellation of a signal, noise will knock one point into another quadrant, and now you know, your receiver will think, oh, it's a 1 instead of a 0. Now, to some degree, that does not matter. The system is built with forward error correction, FEC, and the handbook will even show you some of the code rates, and actually they're in the table right here, depending on the protection level. So for example, if you have a code rate of 0.5, that means that for every one useful bit of data that the receiver will decode, we're actually sending 2. And forward error correction, a simple way of thinking about it is, if I would repeat every second word, even if you miss some, you'll still get some. Now the other thing with that too is usually it gets scrambled, so the order is out of sequence there as well. But that's essentially the idea of forward error correction. You send extra information so you can recover what it is. So if there's a little bit of a noise built up on the receiver, it may get some bit errors, maybe 10 to the minus 1, as shown, as you mentioned there, but or 10 to the minus 4, I think is what they said right in the table
Correct.
here.
Yes.
It will not affect your audio quality in any way, shape, or form. It just tells you that you got kind of getting close to the edge. But once you reach the edge, unlike analog, you will lose the transmission, of course. At some point, it will just be gone. It will not degrade, it will just be gone. It's the digital cliff.
Mm-hmm. And I mean, that's one of the things that is unique because unlike analog, where you get a lot of static and a lot more static and a lot more static, and then eventually you can't figure out what they're saying. With digital, it's very much a here or it's not. And what we're choosing basically with the modes of operation is where we draw that line, how far out we need to, and I mean, that will depend on your market, on several things. I mean, right down to what the skywave's like today, so to speak. So flipping over to FM, there are a whole bunch of ways to get the digital signal and the analog signal together. And the funny thing is, I say funny, it's kind of cool because if you've worked with HD radio, the techniques used to combine analog and digital there are very much the same for DRM. Correct, John?
That's correct. Yeah, you can do high level combined, low level combined, space combining, which is if you are in North America, you've heard it many times before with HD radio, and the same type of technique can be used in DRM. As with the others, there are many considerations. Space combining certainly is a quick and maybe a lesser expensive way to do it, but and I think you've got a slide coming up pretty soon that's going to show the differences perhaps in the pattern radiation. There you go, the pattern radiation of the antennas, which could be a problem. It may not, because the digital signal is farther away from the analog signal, it may not be as pronounced, but it's still there.
Right. One thing to be aware of, and so I'm going to flip back. So we've shown 2 transmitters with in this case, an ERI combiner running into a single antenna. That's a low loss combiner. And then the separate transmitters, one for digital, one for analog. The cool thing about this is if you've got an existing analog, it gives you the ability to add a smaller transmitter for the digital only, keeping in mind the peak to average power requirements.
Right. That is, and again, when you're getting into digital broadcasting, and the key there is if you have the analog transmitter, like you just said, that is sufficient and new enough that it may not warrant replacement immediately. This might be the better way to do it.
Right. And then, I mean, you could always budget as the analog transmitter ages and needs to be replaced, then you put in the other one and now you've got a main standby.
Right. And in early days, this was, one of the ways to do it. But then since those early days of digital broadcasting, whether it's DRM or HD, higher power single-ended transmitters became available from Nautel all the way up to 88 kilowatts now, So, I mean, it made this, there you go, low-level combining just much more practical.
Right. So what I tell people with HD, and the same applies for DRM, is look at your own specific situation. Work with your manufacturer to see what will work best for you, depending on what you're trying to accomplish. And I mean, folks like John can answer these questions all day long and provide the numbers to show, we can do a cost operation to figure out which one would be cheaper to run or to build, et cetera, and so on. So that's good. Going back to robustness, even in FM, we've got some flexibility there too, Philip. Whether looking at robustness levels and modulation rates, yeah.
Well, exactly. Just like in a table before where we had all of these different configuration modes for AM, FM has the same thing. And in FM, we have 2 modulation modes, 4 QAM with 4 points, constellation points in the constellation, and as well as 16. Of course, with 16, we have 4 bits of information. With 4 QAM, we have 2 bits of information. So 16 QAM has higher data capacity, as you can see on the right. However, if you look at it in a constellation view, the points are much closer together. So noise has a much bigger impact on 16 QAM compared to 4 QAM. So you have to budget more transmission power to get the same coverage. And the difference is in the order of 6-7 dB. There is a lot of studies done on this, and conditions vary a little bit, but it means a lot more power in order to get to higher data modes. However, it may be worth it in situations. For example, if you are on an island, you have 1 transmission tower, 1 site, and all you have to make sure you hit everybody on the island. Well, why not dial up to 16 QAM and budget the extra power, and maybe 1 transmitter can do the job of, well, 2 or 3 in this case. So you really want to look at all of the options here. And then within each QAM mode, you can have various levels of forward air correction, like we mentioned before. With the most robust one, you only get 37 kilobits in 4 QAM. And if you go to the less robust ones that, again, don't go as far, but you can more than double your transmission power, or your bits on air.
Right. And again, that comes back to your specific situation. If you've got, for example, a town with very, very few people living outside of the town around it, then a higher bandwidth system with more information might be the better solution. If you're in a large city or a suburb with lots of other people around, then you may opt to go for a little lower bandwidth to get the signal out farther. So certainly it does depend on your requirement.
Or potentially, if you're looking at a national service and you're trying to cover a larger area with many transmitters, you may be better off choosing less bandwidth, because that would allow you to space them closer together, as opposed to higher bandwidth where you'd have to space them further apart.
Right. So absolutely, again, work with your manufacturer early on in the process. It's much easier for us to be involved early and explain why this or that may be good ideas, as opposed to walking in when the equipment's already been ordered and saying, oh, this isn't going to work. And I've dealt with both in the past. One of the other things is we are dealing with relatively low bitrate audio. One difference to HD radio, the sample rate for DRM is 48 kilobits or 48 kilohertz versus 44.1. So it's something to be aware of. But because it is lower bitrate audio, you don't want to run it hard like we do in a lot of markets with the analog. Now, again, there's always this when you're blending back and forth. I know in a lot of hybrid modes, there's always some concern about keeping the sounds similar. What are your thoughts on that, John? I gotta throw them. Oh, you're muted again. There you go.
Okay, there we go. Yeah, the effort has always been there to try to keep the sound as much similar as you can. However, we also want to present an improvement too. So when we're on the digital mode, then there's nothing wrong with showing displaying or presenting an improvement.
And
Now,
maybe more so than audio processing in the traditional sense, pre-processing might be more important. For example, let's say if your source content has a 50-60 hertz hum that, just due to your electrical, and that's just part of the audio, your codec will try to faithfully reproduce that and spend bits on doing so. If you had an audio processor that can take out things like that,
Try to
then
remove it.
exactly, try to remove it, then the codec can more efficiently do its job.
Yeah.
Right. And a
So
lot of times, sorry,
our
go, John.
goal is to go ahead and improve our technology, improve our broadcasting. So the transition to improved audio, even though it's not going to be identical to our analog, and we probably don't want it that way, is a good thing.
Right. And the other cool thing is, as we move forward to all digital, it's even easier to add those improvements if you've
Yep.
already started them early on. I'm going to let you keep talking for a bit, John, because we've got a few slides that include some pictures that you took over the years.
Yeah, we're very proud of this installation here, and what we're going to be showing right now is something that was a real shot in the arm for DRM technology, and that is the initiative that All India Radio started about 10 years ago when they had planned to convert a great many of their AM radio stations to digital. And we call it the world's largest DRM-30 deployment. There, the map shows many of the transmitter sites that are on the air operating in DRM. Nautel supplied 33 NX series high-powered transmitters, 100 kilowatt, 100, 200, 300 kilowatt transmitters for this project, as well as new antenna tuning units, feeder lines, electrical, and so on and so forth. And this is in addition to some other transmitters that they either converted or installed. There are, in addition to R33, there are, I believe, 6 20 to 50 kilowatt Harris transmitters that were purchased at that same period in time. So as a result, 70% of the landmass of India and nearly all of the people, 99% of the population, can receive DRM broadcasts on existing frequencies. And we're quite proud of it because of the technology feat that together between DRM, Nautel, some of our partners that supplied things like ATUs accomplished, and it continues to ensure that news and information vital to everybody's everyday lives, hundreds of millions of people in India, can still receive it as well as entertainment.
And so on our side of that, of course, that's using mostly NX series transmitters. And so the marketing guys made me put this slide in.
They are, that's correct. What we used in our part of the tendering is we use our NX 100, NX 200, and NX 300 kilowatt medium wave AM transmitters for new installations. Jeff, I think your next slide might show. There we go. That's part of the installation process. Just they're kind of fun to look at. You see the RF test load up being installed there on outside a building, and to the right there is a 200 kilowatt transmitter in the process of installation. The lower right is an antenna tuning unit. Jeff commented on the remarkable, fascinating soldering work on those
copper panels,
panels around there. Right, exactly. On the left, the man there is adding onto a building to accommodate everything. They did a great job, and following just some fun things that those of us that have been in the trenches like the new feeder line on the left, and then you see the base of the tower there with the Austin ring transformers there.
And those I'm going to say I've seen a lot of Austin rings. Those are some serious size on those ones.
Simply a couple of self-supported towers at another Mumbai, India transmitter site. You see in the background, the guys are they're in another building, another tower there, and at again Mumbai. They've got several different transmitter sites here. Here, this is a nice shot to look at. These are a pair of 300 kilowatt Nautel transmitters installed in South Korea. It's a Jeju Island, and they are DRM capable. You can see some of the equipment in that rack toward the left there. And it's a nicely done installation by our customer there. And then next, I think, This is one, Jeff, you can talk about this, Philip, too. This is our most recent high power Nautel installation. Antenna Hungaria replaced an aging Russian built 2 megawatt, 2000 kilowatt, 2 million watt medium wave transmitter on 540 kilohertz with a Nautel NXC 2000, which are 400 kilowatt transmitters. There it is, operating in DRM. As you can imagine, because it's such high power and such a good frequency at 540 kilohertz, the coverage is just remarkable.
And it's also, for what it's worth, running into a half-wave single-stick antenna. So it's open feed line. There's no discrete tuning units. It's all done with stubs and basically by running the feed line.
And you know what? And as well, that's incredible all by itself. But then the power savings that the customer is realizing every single hour is incredible. I believe Wendell Lonergan, our head of senior head of sales, calculated it, and I forgot the number. You remember the number, Jeff or Philip? Is it like $118 an hour savings or something to that effect? It's
It
incredible.
was well over $100 an hour. Yeah, it's a significant number. Dave Raitner asked about NX25 and NX10 being able to be updated for digital hybrid, and regardless of mode, Dave, yes, they can be. As to approximate cost, I'm going to have Jeff Wilson, our West Coast sales guy, reach out to you directly on that because, of course, depending where you are in the world, that may or may not vary. Dilhan Santha asks, why DRM receiver not in mobile phones? And that is a really good question, but we look primarily at the transmission end, so I can't really answer why they don't put the receivers in smartphones.
I'll simply add that they are working toward it. And Philip, you were going to say something too, right?
Yeah, the AM side is challenging just because of the receive antennas. It's going to be very challenging to have AM in smartphones, period. Now, the FM side is a different story. Just like you could listen to FM receivers using your headphones as an antenna, certainly it is feasible that DRM will be received the same way at some point. Today, there are options of SDR dongles for your smartphone. And that is certainly being demonstrated and is certainly working to work fairly well. But they require a little add-on dongle to your smartphone, and then there is already the smartphone apps to do all the presentation layer, you know, the decoding of your audio, the text services, the graphical services, all of that stuff is already there. But once smartphone manufacturers open up the API to allow more direct access to an FM receiver, it may be feasible for DRM to just simply pick it up off air, but we're not there today.
Right. Now, at this point, Philip, we got about 10 minutes to go. We can go a little bit over if we need to, so that's not a challenge. I'm going to give control of the mouse to you, and you can tell us about some of the other cool testing that you've been doing in India.
Right, John did a great introduction about the AM DRM project in India, and more recently we're now switching over to the FM band and trying to figure out what is the best standard for the FM band, and we've done a lot of we've helped out with a lot of testing, and we're just here to show sort of our involvement in that. There's many aspects to that. But we're mostly focusing on the parameters of the various standards and how it affects the transmitter. All the different feature sets. Again, this is not a shootout between A versus B, to borrow your words, Jeff. But we wanted to sort of focus on the transmitter aspects. So of course, the FM band. Whoops, here we go. As you can see, the FM band is full in many places, particularly in cities, and we've taken this shot thanks to our colleague Alex Hartman with the Nautel Looking Glass receiver, and you can see here is a full FM band in his market. It is very hard to find new frequency allocations. Particularly high power allocations are very hard to come by. and if there's already existing allocations. And typically for analog FM, we're talking about 20 to 30 receivable signals in anywhere in the market. It's also expensive to install many new analog FM transmitters, if it's even possible to do so. And that makes it difficult to set up a new nationwide service if you want to do that. So we've asked the question, can we achieve that using digital multi-channel audio services? And the solution here really is that for the FM band, we can actually unlock new channel allocations using digital broadcasting. Both HD radio or DRM are in-band standards that allow you to do that. And we'll show you how it can be done in 400 kilohertz, interleaving 400 kilohertz analog and digital stations, for example, and also by combining multiple stations within a single transmitter. And we can show up to 12 to 18 audio services in a single transmitter, single antenna, and it makes it really cost effective to go digital and create new channels that didn't exist with analog FM broadcasting. So here is a look at DRM and the FM band, as well as HD radio on the left, and we tested both in India on the same transmitter, just switching modes, A versus B. And on the left, we see HD radio with 2 sidebands to either side of the analog FM signal, with up to 4 digital audio services along with the FM. In the center, the DRM block, well, it looks remarkably like the AM block. It's just a rectangular block, but this time in the FM band, 96 kilohertz of bandwidth. So it was just half an FM channel allocation, and between 37 and 186 kilobits, as we've seen earlier. In FM also, we have simulcast options where you can place a sideband to either side of the analog carrier. In this case, it doesn't matter that's on the right or the left because we only have a 96 kilohertz option in this mode, so that the same concern for AM does not apply here. Moving on, as I mentioned, we can unlock new digital channels by placing multiple digital transmissions in one transmitter. So on the left, and I'll go into a little bit more detail in a little bit, is an example of filling 600 kilohertz with HD radio signals for a total of 12, and we've even shown up to 15 audio services on a configuration like that. On the right, we have 6 DRM signals all put together. And what is different between analog FM and digital transmission is that a receiver can perfectly pick out any one of these signals without any frequency guard. That allows us to really tightly compact both signals and get a high density of audio services, but only if they're coming from one transmitter. So we've asked the question, how can we fit such a signal into the FM band? And that's certainly a question that's been raised several times from our customers as well. So first, we need to look at a little bit at the existing analog FM protection ratios. If you have a desired 25 kilowatts station in the center here, then and I'm using the Canadian rules here because I'm most familiar with them, but on a code channel, it means that in your protected contour of the desired, you have to ensure that another station in another city on the same frequency has less than 1% received power. So it's a 20 dB difference, 1%. Now, if I want to put a station 200 kilohertz away, now that relaxes to 6 dB or 6.3 kilowatt. If we're moving out to 400, that goes up a lot. Now it can be a lot higher than desired. And the reason for that is the channel selectivity of a typical FM receiver. It will filter out anything that's further away from your desired. So that allows you to have more signal content in that area. The plus with that is, well, we could potentially put more power adjacent to our FM channel. But the negative thing is, and that's particularly true in North America, well, somebody's already taken that allocation. But depending on where you are in the world, the 400 kilohertz spacing might be a possibility for you. You'll have to look at it. Now, HD radio recognize that there is white space, 200 kilohertz from that because of this sort of relationship. And they've placed 2 sidebands on either side. And the rule of thumb is about 10% of HD radio power is the same as FM power. So we're going to use that same rule of thumb both for DRM and HD radio, but it does vary on the situation. Now, if we're looking at DRM, the single sideband, well, the interesting thing there is, well, first of all of the power is now in one sideband as opposed to spread across two. So you'll have more power on one side. But the interesting thing is, as we're moving out away from the FM, it allows us to add more power to it. And coming back to the DRM handbook that Jeff mentioned earlier, they've got some excellent research in there, depending on how far away you are from a desired FM station, how much power you can put in the DRM. And the rule is the further away you go, the more power you can give it. We've even shown in India that we can have equal power to the FM without negative effects on the FM. So certainly there's a lot more possibilities the further out you move. So how can we make use of white space in between allocations from the same transmission site? And the real game changer here is digital only needs about 10% digital power, rule of thumb again, but it needs a lot less power than an FM allocation. That means it's also interfering less. And that allows us to make use of white space, similar to LPFM. But in this case, the difference is we're getting more coverage with digital compared to analog. So to explain that a little bit more, let's say we have three code channels on 93.5 in this case. Each, let's say they're all 25 kilowatts at 100 meter, and that could be a 10 kilowatt transmitter with 4 dB antenna gain. We're getting about 50 kilometers to protected contour, but don't forget about the interfering contour. And the Canadian rules recommend a station like that should at least be 236 kilometers apart from the next one. If they come any closer, we consider them short-spaced. And there are certainly ways that you can do that, but you need to mitigate the short spacing, make sure there's no interference. And on each one of these transmission sites, you may have multiple allocations, 93.5, 94.3 in this example, and a lot of times they're 800 kilohertz apart. And that could be on all three of those potentially. So combining that with what we learned in the previous slides, 200 kilohertz apart, you could actually place an FM allocation much closer. So we're going down from 236 to 136 kilometers here, and that could be at 93.7, 200 kilohertz apart. So what that means is if we wanted to also put a digital transmission at 93.7, we need to make sure that we limit the amount of power here, so that that our interfering contour does not get into the protected contour of the already existing 93.7. But there is still a significant amount of power here because again, it's a 10-to-1 ratio that makes a difference here. And if we don't have any code channel on 200 kilohertz separation like shown on the right here, then the only thing to worry about is our host interference or the interference with the FM. So we can crank up power here. Now, the interesting thing is with 400 kilohertz apart, well, there could be an FM allocation much, much closer, and it could even be closer than that because the interfering contour is actually smaller than its protecting contour in that case. So it could be much, much closer. But I would argue here, if you move that green circle closer to either of the 93.5s, then it will be hard to reuse that same frequency anywhere else. So likely it will be somewhere in the middle. So what that means is we may have to tune down our digital transmission at the 400 kilohertz separation in order to protect that station as well. However, if there's no 400 kilohertz code or 400 kilohertz allocation anywhere, well, we can really crank up the power because our FMs at that site don't care anymore. So now we can actually put some significant power behind it. So you need to look at each situation depending on where you are. So here's an interesting way to think about this. We could use both HD radio or DRM FM to fill 600 kilohertz. I've shown you we can put 600 kilohertz of digital content, and it actually fits nicely in between two 800 kilohertz allocations. The difference between the two standards on the left is because there's two sidebands for HD. You'll have 3 tuning frequencies. The one associated with the green, orange, and bluish would all be their own dial frequency, with each one providing 3-4 audio services. DRM, on the other hand, on the right-hand side, is 6 individual towers, and each one gets a tuning frequency associated with that particular frequency allocation. Let's go through that in a little bit more detail next. So how do we make all this happen? And I don't want to go into a lot of detail here. Certainly anybody interested, we can talk more about this. But the key thing to take home is we can only put digital signals close together like that in a transmitter if they're perfectly aligned in time. Each digital symbol on each transmission has to start precisely at the same time. And they all have to be perfectly synchronized in frequency, which means you best achieve that using a single modulator that can handle multiple independent inputs. So it all has to come from a single exciter, a single modulator that then feeds our transmission. Now, each one of these modulators and content servers or exporters, importers in the HD world, they could be independent. They could be run by different broadcasters. They can be managed different, allocated differently. It's the transmitter that now becomes part of the common transmission infrastructure. And that's the game changer here. We're all used to combiners being part of shared by multiple broadcasters even. Can we share the transmitter itself? That is one of the key questions. So in Delhi, we've demonstrated those 600 kilohertz modes. And on the right-hand side, we've got the DRM-FM with the 6 tuning frequencies that we showed there, with up to 18 audio services in that case. And on the left, I've color-coded the various HD sidebands because they always come in pairs. We've also shown that in 600 kilohertz with up to 12 audio services. And the interesting thing with HD radio is we can trade off, just like if you're familiar with the asymmetric sidebands and standard HD radio transmission, we can also trade off power between the two sidebands to make it fit better to your requirements. And all this was shown using our VS2.5 transmitter on the left. And that, again, like I mentioned before, we demonstrated both HD radio and DRM in the FM band for all of these. Same transmitter for it all. It's just a different exciter modulator software implementation. So then the next thing that we wanted to look at, or that the test in India required, is how do we work that? You know, the previous slide was a dedicated antenna in Delhi, dedicated transmission, easy breezy that way. But how do we fit that into a common transmission site that already has, in this case, 6 FM allocations in band? And the interesting thing to note here is that once you add FMs into a combiner, they will all add destructively and constructively. So the constant envelope FM signal from one transmitter across 6 will create significant peaks, 360 kilowatts in this example. When we upgrade, and that's certainly a possibility, we can upgrade all the combiner inputs, make them wider in bandwidth, but make each one of these stations a digital station. I've shown both HD and DRM because that applies equally to both. We need to make sure that not only do we have enough bandwidth on the combiner input, we also need to make sure that the overall peak power, it increases, and that depends on your injection ratios and a number of parameters, but you need to make sure your antenna can still handle that. So, you know, new sites, no problem. I think we just need to budget for it, but can your existing master antenna, master combiner handle a digital transition? So the other option, we've already mentioned that earlier, is, well, certainly initially, we can look at separate antennas. And that was the case in our India tests, where we now moved to a different site, and the Jaipur site was selected. And in this case, there were already 6 existing FMs there, but we've installed a separate antenna to put on digital signals. So on the left here, again, we see the standard HD radio configuration with the 2 sidebands and an FM. And the right hand was the single DRM configuration in this particular case. And the spectrum analyzer shot taken just off air with both of those signals in there. And certainly, you know, you can place signals in between there, and there was no noticeable impact on the other frequencies, the other existing FMs. But to make more efficient use of this available spectrum in there, well, on the right-hand side, we tested 4 DRM sidebands to fill out that space more efficiently. And in this case, DRM can produce up to 12 audio services. And then on the left, we've also shown HD radio in a 400 kilohertz configuration. And the interesting thing to note here is that the two blocks in the center are essentially single sidebands. They've lost their partner on the outside. And in order to get better or comparable coverage again, we had to make up for that loss with more power. So that's why they are raised in the center. But they're still receivable. There's enough forward error correction in the HD radio signal to be able to operate on a single sideband. Now, to make more optimal use of the entire 600 kilohertz available between the FMs, one interesting configuration that I think is quite interesting for DRM is to actually use 5 DRM blocks in between an 800 kilohertz allocation. And the reason for that is all of the DRM tuning frequencies are now back to 100 kilohertz tuning. And I forgot to mention in the previous one with 400 kilohertz, they are in 50 kilohertz increments. But now they're back to 100 kilohertz tuning with 5. And then the interesting thing is, should the outer FMs decide to convert to all digital DRM down the road, they can do that on their existing 93.5, 94.3 allocation. And it fits nicely with the other 5 that are there now. And then we can leave one block as a frequency guard band because it comes from different transmitters, different antennas. So in that case, it would probably be best to leave 100 kilohertz block free. Now for HD radio, we've used the entire 600 kilohertz because, as I mentioned before, we're able to drop the outer sidebands to a level that we're not interfering with the FMs on the outside. And we can bring them down to lower levels than would normally be used for HD radio injection. So we can make effective use of the entire 600 kilohertz in there. But both standards are very applicable to a solution like that. It was tested and it was received well. So this solution, well, we can look and see if we can find some white space at those reduced power levels and add new digital channels. So that's certainly a possibility moving forward. There's certainly a lot more to talk about this kind of topic here, but I think it's probably best that we leave it here today. And I just want to reiterate some of the key points. 10% transmission power in digital unlocks some white space. We can create a lot more audio channels in the FM band. And by using a single transmitter, single antenna, we can reduce operating costs, initial installation, and overall just make more effective use of the spectrum that's available to us. So I spoke a lot here. Are there any questions that come to mind?
There are several. So I'm going to grab control of the mouse back here and just scroll up. There were a few that came in. Joel Epley made a good point that in the US, at least, the interference thresholds are complicated because how protected contours are calculated versus interfering contours is different, 50-50 curves versus 50-10. Yep. So that is a good point. And that certainly, depending where you are in the world, the requirements are different. Flipping back to the low band DRM, the DRM 30, Naveen Nambani asked if we'd done any shortwave and long wave, and we don't build shortwave, but we have done long wave, right, John?
Yeah, we have done long wave, and with great success. And again, you're right. We don't build shortwave transmitters, but we're acutely aware of shortwave installations, including a couple in India. And there are a number of, to my knowledge, in China, there's a number of shortwave stations that are on the air in DRM as well. But we have done long wave, certainly. Long wave, certainly. I don't know the locations of those, Jeff. I'm sorry. I'm not aware.
Well, we did one in Denmark. I think it was 2011. It's a few years ago, but we've modified an NX transmitter operated at 243 kilohertz, and I think it was a 300 kilowatt, or it's a substantial power, and that was in Denmark.
So Joel asked another question, Philip. If the center OFDM carriers in HD were increased in power due to not having corresponding sidebands, doesn't that mean that these carriers would contribute even more dramatically to PAPR?
Oh, absolutely. Well, any of the digital transmissions have significant PAPR, and one of the key contributions that we're adding to make it even feasible to go through a single transmitter is through better PAPR or crest factor reduction That's what it's called in some cases. And that's where Nautel's unique contribution, our unique IP is coming in place. We have an algorithm that can look at all of these different configurations, whether they're single sideband HD, or whether they are DRM blocks. The idea is you need to do PAPR on the summation of all of these. And there's a few unique aspects that we've discovered to enable us to reduce the peak to average power ratio significantly and get significant power out of a transmitter.
Very good. And Jim Delkey asked, the current HD car radios decode DRM, and that's those are two totally different technologies as far as the software goes. So I'm guessing the answer is no. Is there a multi-platform receiver that you're aware of yet?
Oh yes, there's several. And typically they're different firmware loads made from different manufacturers, but it's one or the other. Yes, the same chipset could be loaded with different firmware, but practically in a car, it's one or the other.
Okay. Oleg is asking, what's the efficiency of a transmitter when you're amplifying multiple digital signals?
That's a very good question. It's a little bit early on as we haven't studied exactly every transmitter size and model, but for reference, we do have data on DRM in and of itself, as well as HD only without DFM. We have the HD only mode in our transmitters. And I think those would be good estimates, good ballpark numbers at this point. For efficiency, because the one thing that we've noticed is that as we add more bandwidth, more carriers, more digital carriers, you're spreading the power and the frequency, if you want to think about it that way. It does not necessarily affect, with the right algorithm, does not affect parameters like efficiency and sizing. So you could, for example, have one DRM signal in, let's say if you can have one DRM signal in a 10 kilowatt transmitter, then you can put two in a 20. It scales very nicely like that. And one of the advantages of that is, of course, as you go up, you're making better use of, transmitters. The dollars per watt in the transmitter decreases as you go up in size. So it becomes more efficient from that point of view, from an operating point of view and initial CapEx, to go with a bigger transmitter handling several stations, as opposed to many transmitter handling one each.
Well, and that comes back to the fact that 10% of digital power will cover roughly, and I mean, I'm ballparking obviously, but roughly the same amount as the analog. So you can stack a lot of digital signals together before you've hit the same amount of analog power as one transmitter.
Exactly.
Let's see. Are you planning to develop envelope tracing or EEP?
Those are very detailed questions that we won't answer at this point.
We tend not to give away where we're going. On that note, we are pushing close to 15 minutes past the top of the hour, so we've run long. I do want to throw a couple of resources. Again, a shout out to the folks at Digital Radio Mondial at drm.org, and the DRM handbook is arguably one of my favorite resources as of not too long ago, and I'll be spending a lot more time with that over the next few days. Definitely, again, Nautel, we can, this is a link just to search DRM. We've got a search window. You can search various terms and get different papers and topics. Over and above that, we have our Waves newsletter. I think there's one came out in February, so we'll probably do another one in the next week or month or something like that. This webinar and all of our webinars are archived. You can access them through the webinars link on our website under resources, or through our YouTube channel. Beyond that, on the YouTube channel, the tech support guys have got some handy little tips and tricks of things that they get a lot of calls on and want to help you out. I'm going to give a shout out for my Transmission Talk Tuesdays, a little informal roundtable we do every Tuesday. I won't say every Tuesday, a lot of Tuesdays, any Tuesday that I can pull myself free. So on that note, folks, I want to give special thanks to John Abdnour for spending some time with us. Is not so much this, but we did an early morning practice, and it was really early in John's part of the world. And Philipp Schmid, our CTO, again, thank you very much for spending the time with us.
Jeff, it's a pleasure. Philip, it's a pleasure to always work with you, and just wish everybody that's viewing and listening to thank you and stay well, stay healthy, everybody.
On that note, folks, thank you very, very much for spending your time with us. Again, we hope to see you next time. Have a great day now.